So welcome to my YouTube channel once again. In this video, we're going to continue looking at the simultaneous equations problems, this time around from an economic application perspective. So I have the equation here on the screen. Solve for price P and quantity Q in the two demand functions given as question 1 and 2. Yeah, so this question is an economic application question. So since the question was given in the form of demand functions, we have to make Q the subject formula, since quantity Q is always a function of price. From the law of demand and supply, the higher the price, the lower the quantity demanded, meaning that we have to put the equation in proper form as far as economics is concerned, because in this case, the equation is showing as if price is a function of quantity. But whereas economics let us know that it's quantity that is a function of price. So in solving, all we need to do now, we say therefore, from equation 1, equation 1 is P equal to 800 minus 0.4 Q. So we make Q the subject formula. We have 0.4 Q equal to 800 minus P. And then we have Q is equal to 800 minus P divided by 0.4. So we can come to this side. Our equation will be Q is equal to 0.4 divided by 800 will give us 2000, and then 1 divided by 0.4 will give us minus, will give us 2.5. Sorry, sorry, just a minute. Will give us 2.5 P. Yeah. So we can properly see this is our equation 1. Yeah, it's still the same equation 1, just that we actually put it the way the law of demand says the function should always be in. And then the second equation, which is P equal to 620 minus 0.2 Q. Making Q the subject formula, we have 0.2 Q equal to 620 minus P. And then we have Q is equal to 620 minus P divided by 0.2. Our Q will be equal to, so when we divide 620 divide by when we divide 620 divided by 0.2, we are going to get 3,100, and then minus 0.2 divided by 1 will give us 5p. So we can equally say this is our equation 2. So the proper equation will be in the form Q, or let's go to the next page, will be in the form Q equal to 2000 minus 2.5 P. This is our equation 1. And then Q equal to 3,100 minus 5p. Then this is our equation 2. This is equation 1, this is equation 2. So from here, we can just solve directly using the equating method. And we know that the equating method demands that we should equate Q equal to Q. That is, the quantity function in equation 1 should be equated to the quantity function in equation 2. And once we do that, we're going to get 2,000 minus 2.5p is equal to 3,100. Sorry, yeah, 3,100 minus 5p. So we solve for this, by collecting like terms. So when we do that, what we are going to get is minus 2.5p plus 5p equal to 3,100 minus 2,000. Yeah, so what we're going to get here is 2.5 p equal to, and then 3,100 minus 2,000 will give us 1,100. Yeah, so we solve for p. P is equal to 1,100 divided by 2.5. Our p will therefore be 440. Yeah, so to get the value of our quantity, we can substitute the price, the value of price into either equation 1 or equation 2. So let's solve for both. Let's say from equation 1, substitute p equals to 400. Sorry, p equals to 440. Therefore, our equation 1 is q equal to 2,000 minus 2.5. And then we already know our p to be what? 440. Yeah. So q is equal to 2,000 minus 2.5 times 240 will give us 1,100. And then our q will be equals to 2,000 minus 1,100 will give us 900. And then we can also say from equation 2, substitute p equal to 440. Yeah, so our equation 2, we have q is equal to 3,100 minus 5. Already we know p to be what? 440. So our q will be equal to 3,100 minus 5 times 440 will give us 2,200. And then our q, when you subtract 2,200 from 3,100, what you get is 900. So you can see that using either equation 1 or equation 2 will still give us the same quantity demanded. Yeah, so what I want to say in this very equation is that it's possible for one to solve directly, since it is simultaneous equation and it is equating method. Solving, equating p equal to p will still give the same answer. But as far as the law of demand is concerned, and as far as economic students are concerned, once you're given a demand function, you put it in proper form, put it in explicit form before you go ahead and solve. But what I'm trying to buttress here is that solving it this way, will give you the same answer as well. But it may not give the same marks, especially if it has to do with exam or tests or any kind of assessment, because you have to apply the law of demand first before you solve the question. So thank you very much for staying. Thank you very much for staying up to the end of this video. Please, you can kindly share the video, subscribe to my YouTube channel, and comment wherever you think there is any observation or there is any problem that you want me to solve. So thank you very much, and I appreciate. Have a nice. Bye bye.